Okay, so I finished the hollowing cutter. The project I started out to do is now done. Okay, so this entire thing is built from grasshopper geometry, not using any rhino geometry at all. Okay, every curve curve is created by a parametric entity inside of grasshopper. So quickly, a little bit about what this enables us to do, and unfortunately it's not really fast, is I've created a ring, essentially an eternity band, sorry, not an eternity, a solitaire, with a single stone in the shank. Doesn't seem very complex. Unfortunately, it is actually quite complex when you do it in the parametric builder, which is why I'm looking at 3 design. I suppose the easiest way to show you what it does is let's export some geometry and move it out the way, and let's have a look at what it is we really have. So what you have is you have one entity, which is your ring, which is a standard shank. It's been hollowed to an even wall thickness all the way around, and it has a separate collet on it because you may want to cast the collet in a separate color and drop it in. Alright, could have just as easily been booleaned into the same piece. The collet is cut to fit the shank perfectly, and all of the geometry is valid. There's no issues. Alright, so the question becomes then, alright, you've drawn this ring for a client or for a customer. They've gone, look, we're going to order 10,000 of these things, and we find that we need them all to weigh 1/4 gram less. Alright, so let's move this guy out the way. Let's examine that geometry as we have it there. In that is at a finger size 15.9. Customer's happy with all of that. They're buying it in 9 carat. It's 3.14 grams in our little panel over here. They want it 1/2 gram less at 2.6 grams. Okay, so where can we steal 1/2 gram? So let's examine the ring. We know the factory can cast to a wall thickness of 0.3, so let's take it down from a wall thickness of, okay, that's dropped 0.1 by taking the wall thickness to 0.5, and that's doing it evenly right around, okay, around the inside over there. 0.5 only got us 0.1 of a gram. 0.4 is starting to become dangerously thin, so let's go, okay, we can't hollow it out anymore, so maybe let's extend the hollowing down further into the base. So that little builder over here is the hollow distance, so I can reduce it. Let's take the hollowing distance further down into the shank. Alright, if I take it down to almost the bottom, so you've just got enough space left in there to do a hallmark, you get down to about 2.85, and we still haven't changed much about the actual look of the ring on the outside at all. Okay, we can choose to hollow all the way down, but that's not generally accepted practice. Because the next thing we can start looking at is our bottom thickness of the ring is currently 1.8, which is quite heavy for mass production. So we can bring the bottom thickness of the ring down to 1.4, and we got to 2.7 grams. As you can tell there, we've got 0.2 of a gram to go. Our side wall thickness is 1.6. I don't really want to mess with that. I'm just wondering where else we can steal a bit of weight. Maybe if we make the collet a tad thinner, so the wall thickness on the collet, the bezel thickness, let's bring that down to 0.9. That took 0.1 of a gram. And we've quickly dumped about 1/2 gram on this ring so far without radically altering anything. The only other things we can still probably change now is to bring this down a little bit, maybe reduce the height in the shoulders. So let's bring the shoulder heights down a little bit. So the ring top thickness from 3.2 down to 3.1. Whoops, okay, I went too far down, back up 2.8. Okay, at 3 we have 2.56 grams. In 9 carat we've achieved what we needed to do. Visually there's not a hell of a lot of difference between them, so let's export this geometry too, and so now you have this variant of a ring. Okay, so fantastic, we're all good, customer's happy, ring looks good, it's structurally sound, it can be produced. Okay, now the customer's going, alright, well now I need it in K, L and M, so let's bake one at a smaller finger size. So export it and let's pull it out there. Alright, they're saying, well, we like it at the smaller finger size, but we want it for a variety of stone sizes. So grab your stone size and go, alright, we want it in a 5mm stone. Let's bake that one. Oops. Okay, and we also want it in a 4 millstone. We're going to see what happens when we do that. So when we bake one for the 4 millstone, we're still inside of our border over there. Okay, the 4 millstone looks a bit silly being that tall, so you maybe want to drop your height down, but that's up to you. So let's bake that one. Okay, and we also want it in the 4 millstone. We might want to try this as a. We might want to try this with a much lower shank. Look, it doesn't matter whatever it is that you're building. You can change the parameters of this. We want to reverse the taper on the small one. So let's make the top width of the ring more. Let's make the bottom width less. Okay, so we've reversed the taper of the ring. Okay, so we now have a ring that looks that way around. Okay, the top taper was too much because the collet is not sticking through quickly without having to do anything else. We've got her sitting there. Alright, so now we can export that ring. And you're starting to get the picture here. It's far less work once you've generated it in this way to go in and make hundreds and hundreds of iterations as required. Right, so I'm going to delete all of those and explain to you guys how we arrived at this geometry. Alright, because the building process is reasonably complex. It doesn't take particularly long. Something like this, if you drew by hand in Matrix or Rhino, would take you, I don't know, 5 minutes, if that long. It's a dead simple ring. Doing it parametrically can take anything up to half an hour because it's quite a complex thing. So what I'm going to do is I'm going to pull the grasshopper window for this over to there and full screen that and just kind of walk you through what's happened. Okay, so we start with all the sliders that we set up. Just a note about what we're looking at. If you see these little squiggly guys over there, it just means that I've hidden some lines because I'll show you, if you highlight all of these things, when you're trying to build something, the connections between layers can become incredibly complicated. So as I finish off one thing, I highlight and go like, well, there's my hollowing cutter, see? And I group them together, and then I hide all the wires that connect it. There's my finger hole cutter, we'll get to these in a minute. My collet. Alright, the base ring, I've left the wires in so you can get an idea after I've explained how the base ring was built, how we arrived there. There's some Visual Basic coding, which probably is the only thing that maybe wouldn't be intuitive to most jewelers. There's some degree of written code in Visual Basic that needs to be done in terms of calculating the math for where stuff is offset. Alright, so I'm going to see if I can move this to over halfway there and see if we can move this window like that so you can kind of see what it is we're working with. Alright, and I'm going to hide the actual ring. Let's hide all of that. Okay, so we've got nothing on the screen. I'm going to start sort of from scratch. Alright, so if I show you all of these items, if I make them visible, you can see what I've done. I've started by creating a plane in the background, giving it 4 X and Y points. I've created the points which are over there. I've moved them to specific areas based on the relative size of my ring. So I have a minimum X and Y in the finger size in terms of left to right, up and down. But then I also have, over the finger size, I have a ring thickness, which is up here. So in the VB code here, there's this plus this offset by the width becomes that point. Okay, the finger size plus the width becomes that point over there, that point over there, that point over there, that point. So I've got the 4 points over here. The reason there's 4 points is because the ring obviously is either side of center, so you need points mirrored either side of center. I'm going to turn those off again and turn the ring components on. Okay, and essentially to make the ring, we've created a plane from those 4 points. I've created a curve, you'll see it in here somewhere, there we go. I've created a curve to run between the 4 points that represent the inner circle, which is the finger size, plus the ring thickness, which is, like I said, the ring thickness is denoted by ring top thickness, ring bottom thickness, ring side, which is the same on both sides, so it's just mirrored. So finger size plus plus plus. I've got 4 points, a point there, point there, point there, and I've created an interp curve between them, okay, which is I've then projected against this plane the finger curve and that, and then what you're not seeing over here is I've mirrored this plane, I've mirrored the curves that are here to the other side. Let me maybe hide all the lofts so that you can see what's going on. Let me hide the first set. Okay, so what's happened is I've mirrored the curves over center to the other side. So that's the two mirrors. So I've created the curves. Let's turn them on. I've mirrored them over there, and then I've done two lofts and two caps and a Boolean difference, right? Which has resulted in, I'm going to hide all of those, which has resulted in this surface. Okay, what you're seeing, the cutout over there, is this over here. So by the same process of creating a couple of surface and curves and lofts, I've created the collet. Okay, so if I show the collet, let's hide this again. So if I show the collet tools, you can see that I've created two curves, extruded them towards the center, and simply done a Boolean difference with the finger size curve. So the same way that you work in Rhino, nothing's changed. Let's hide all those again. And then exactly the same thing for the finger hole cutter. The finger hole cutter is essentially the same as the finger cutter over here. It's a copy paste of what was used to cut the finger hole out of the collet, except that I've created some special code on the bottom to offset the bottom by a value of bottom distance plus hollow distance. So in other words, I can control how far down the ring the hollowing goes. There's also some VB coding in there. All right, and then the hollowing cutter itself is made from the original extruded surface up here before it gets Boolean, which represents a ring, offset in X and Y and Z by obviously the wall thickness amount, okay, and then Boolean from the inside ring. So really the exact same way that you would consider working with Rhino, you work with this. It's just slightly different tools. So I'm going to show all that again, and essentially that gives you this. All right. It's quite a smart thing to maybe, let me just move that back to the other screen. Helps having two screens to work on. Essentially, once you've done that, now this ring exists in 100,000 different iterations. Okay. At this point in the game, what I'm going to look at is what's involved in running a row of stones down the collet. That shouldn't be too complex. Running a row of stones down the shank. And the stones would then have to taper in whatever direction I choose to taper the ring. So the stone circles would be an array based on an intersection between the top and the bottom of the ring. It all sounds quite geeky, but once you've got the basic gist of it, it's not that hard. And then the weights, of course, are calculated by this little fella over here, which has got some VB scripting in it and some values for the specific gravity on silver 9 carat and 18, and it feeds out to this. Okay. Essentially that's all there is to say about that. For those of you in the Bangkok team who have any interest in learning this, I don't have a lot of time in between shows this time around, but maybe in another visit or through some video tutorials we can discuss the kind of things that you see happening often on your benches that you like us to try and automate using this. I'm also investigating 3 design at the moment. Alright guys, hope that helps. Catch you later. Cheers, Chris out.